Hello, I'm Susan Price. I'm a program manager in the SQL Server database engine, and I'm going to be talking to you today about ColumnStore indexes. I love this picture. This is just what I picture when I think of a user waiting for a data warehouse query to finish. Typical data warehouse queries require processing enormous volumes of data, often joining multiple tables with filters and aggregations. And waiting for minutes, even hours, for queries to finish is all too common an experience. ColumnStore indexes are all about changing that user experience, speeding up those queries so users don't have to wait endlessly for results. So today I'm going to talk about first the benefits of a ColumnStore index so you'll know why you want to listen to the rest of this talk. And then I'm going to show you a demo that will really convince you to pay attention. Then we'll look at what ColumnStore indexes are and how they speed up queries and how they take advantage of the new batch mode query execution. Then we'll talk about how to use ColumnStore indexes, and I'll tell you a little bit about some early experiences that our customers are having with ColumnStore indexes, and then get into some best practices to help you take the best advantage of your ColumnStore indexes. So benefits. ColumnStore indexes are all about speeding up query response time and allowing you to have a more interactive experience with your data. And that results in easier data exploration, and then you can make better decisions based on that data. ColumnStore indexes also can reduce the effort needed for physical database design. In most cases, you'll be able to get rid of your other non-clustered indexes, which reduces both design and maintenance costs. It can also reduce your need for summary aggregates and indexed views. And if you use OLAP cubes primarily for query performance, you may be able to get rid of your OLAP cubes as well. Now, if you like using OLAP because you like MDX and the rich modeling capabilities, then you can continue to use them, of course. The other thing is that ColumnStore indexes are transparent to the application. You don't need to change your application to take advantage of the query performance provided by ColumnStore indexes. And the result of all this is that you can use less hardware for a particular workload. And of course, what that really means is you'll probably process more data using the hardware that you have. So now let's take a look at ColumnStore indexes in action. What I have here is a version of the AdventureWorks DW 2008 database with one addition, and that is a copy of the fact reseller sales table that has been blown up from just over 60,000 rows to having 100 million rows. Now, this demo is all running on my laptop. This isn't going against a big server anywhere. And on this fact reseller sales table, it's been partitioned. There are 26 partitions, so it's called fact reseller sales part. And there are two indexes. There is a clustered index, and there is a non-clustered ColumnStore index that I called NCCI. Now, what I have here is two identical scripts with queries that will be typical data warehouse queries. But in one case on the left, I'm going to use an index hint to tell SQL Server not to use the ColumnStore index. And what you'll see here is I could use the with index hint to tell it to use the clustered index, and I have that commented out. Or you can use this new hint, ignore non-clustered ColumnStore index. And that's the one we'll use. But either one, you'll see the same results for this query. And then on this side, I don't have any query hints. So SQL Server will decide whether or not to use the ColumnStore index or to use the clustered index. So I'm going to get started over here. And we'll do a cold start, just for comparison. And this first query is going to calculate the total sales by region and by year. Now remember, this is without using the ColumnStore index. Now I know that's going to take a while, so let's go over here while that runs and look at the other queries. So imagine you're that analyst in the picture that I showed you who is waiting for his data warehouse query. And after looking at the total sales by region and by year, he wants to drill into those results. So he's going to get the total sales by reseller, by region, by year, and then filter that to be only in the US and only for years 2003 and 2004. So we're doing a join of a big fact table to a couple of dimension tables, we have a couple of filters, and we have a group by. And then finally, we'll look at a year-over-year comparison of those US sales for 2004 and 2003. So those are the three queries that I'm going to show you. Let's go back to the query that's not using the ColumnStore index. It's still running. It's been over a minute now. Now we're starting to really feel like that guy in the picture, aren't we? Just staring at that screen, and it just goes and it goes. And I know this is going to run for about a minute and a half. So let's go ahead and get started on the ColumnStore index. So we're going to do the same thing. We're going, there it goes, it finished, 1 minute and 29 seconds. So we're going to clear out all the buffers again. And now we're going to let that same query run with the option of using the ColumnStore index. You ready? There we go. 2 seconds. 1 minute and 29 seconds or 2 seconds. Which would you rather have? I want the ColumnStore index, personally. OK, so let's look at that second query. We're going to drill down into that data, because we're that analyst in the picture. And we'll do a cold start again. Now this is, again, scanning that ColumnStore index, but we're going to put a couple of filters on it and then group it again. Wow, this time it's only 1 second. Let's look at that execution plan. Now what you'll see, if you go into this execution plan, you'll see that, first of all, we are using the ColumnStore index, doing a ColumnStore index scan. And we're doing it in batch mode. If you look up at the top of the properties, the actual execution mode is batch. And you'll also see that there's this new batch hash table build operator. And that will also tell you that this query is being executed in batch mode. OK, so I showed you a cold start. Let's look at warm start. Now it's even less than a second. Now, is that amazing? And finally, let's look at this year-over-year comparison. So now we have two subqueries scanning the ColumnStore index. And again, filters and aggregation and some calculations on top. Wow, that is really fast. Oh, I got two queries there. Let's do that again. So, well, let's just show you. This last query was just a count star for how many rows are in the table. And as you can see, it really is over 100 million rows. And if we do, let's go ahead and do another cold start, because SQL Server is going to be so fast. And this time we'll get the query without the count star. Yeah, look at that, 2 seconds. Now, I won't show you how slow it is on SQL Server without the ColumnStore index, because it's too boring. But I timed it, and it's about 35, 37 seconds for each of those last two queries. So let's go back and talk about how these ColumnStore indexes work. So now that you've seen ColumnStore indexes in action, let's get into some details. What is a ColumnStore index, and how does it make those queries run so fast? So traditional database systems store data in row-wise fashion, meaning that all the data for a given row is stored contiguously. Each page has data for one or more rows, and when the data is retrieved, you bring back all the data for each of those rows. Now, I like to think of the ColumnStore index as turning that model 90 degrees. We store data column-wise instead of row-wise, and that means that the data for a single column is stored contiguously within a page, and you have a set of pages for each column. Now, there are two big benefits of doing that. So first of all, by storing all the data for a given column together, there's a lot more redundancy and similarity of the data within a column as compared to across a row. So you can exploit that, those data characteristics and get much better compression. Now, SQL Server 2008 introduced page compression, which really provides great compression. But the ColumnStore index is almost 2 times better than page compression. And that means you have less I/O and more of your working set can fit in memory when you're processing queries. Now the other big thing is that by storing the data for each column independent of the other columns, we can access that column data independently. And that means for any given query, we only have to fetch the data from the columns that are needed for that query. And typical data warehouse queries only touch 10 to 15% of the columns in a big fact table. So if you think about it, you're reducing your I/O costs by 85 to 90% just right there. So we're compressing the data, we're dramatically decreasing I/O, but there's also more. The ColumnStore indexes work with a new query execution mode that we call batch mode. And batch mode processes the data in a vector-oriented way, meaning that you take a set of data from a column and process it all at once in a very efficient fashion. We also use a new compact data representation and some algorithms that are optimized to take advantage of the layout of the ColumnStore index and also the characteristics of newer hardware. The parallelism is also better. We've been able to get rid of a number of the exchanges of data between threads that can use up a lot of your execution time. Column stores are also easy to use. As I mentioned, you don't need to rewrite your application. All you have to do is to create a ColumnStore index after you have created and loaded your table. And here's an example of the syntax. We've introduced a new keyword, ColumnStore, and you just type create non-clustered ColumnStore index, the name of the index on the name of the table, and then in parentheses, a list of the columns that should go in that index. Now, it doesn't matter what order you list the columns, and typically you'll put all the columns in your table in the ColumnStore index. And rather than have to type out all those names, you can also use the Create Index wizard within Management Studio to create your ColumnStore index. Now, once you've created that index, the Query Optimizer takes care of deciding when and how to use it. It makes a cost-based decision, just like it does for other indexes, about when to use that ColumnStore index versus a different access path. And it also decides when to use batch mode processing. The ColumnStore index is persisted, just like B-tree indexes, and memory management is automatic, just like it is with B-trees. We've created a new object cache for those ColumnStore structures and a new memory broker that handles allocation between the buffer pool and this new ColumnStore object cache. So although the performance is best when all your data fits in memory, you don't need to worry about whether the data fits in memory or how it's fetched and when it's evicted from the object cache back to disk. All of that is taken care of for you. And the important thing is that the data is not required to all fit in memory. Now, once you create a ColumnStore index, it's optimized for read-mostly workloads, which is typical in a data warehouse scenario. So once you create that ColumnStore index, you can't directly modify the data in that table. What you need to do is you can either use partition switching, which most data warehouses are using now just to make it easier to manage the data lifecycle. And when you want to load new data, you just create the columns, you put the new data into your staging table, create a ColumnStore index, and then switch that staging table into an empty partition in your main table that already has a ColumnStore index. And if you need to delete or modify data in your table, you can switch the affected partition into an empty staging table, disable or drop the ColumnStore index, do whatever modifications you need to do to the data, rebuild the ColumnStore index just on that staging table, so just one partition's worth of data, and switch it back into the partition that it was in previously in your main table. Now, if you don't want to use partitioning, you can also just disable the ColumnStore index directly on your main table, do whatever loads or data modifications you want to do, and then rebuild the ColumnStore index on that table. So now that we've talked about how to use the ColumnStore index, let's look at some real customer results on real data. So here we have some data from real customers. Some of them are external customers, so these are non-Microsoft customers who are from our TAP program, who've been doing testing on some early pre-production builds. And they're reporting query performance gains that are really impressive. If you look at the top one of our customers reported to us a query that is running 340 times faster. That is huge. We have another customer reporting 17 times improvement, and yet another customer who looked at a set of queries, and over that set of queries, they're seeing almost 6 times improvement. Now we also have some results from internal organizations within Microsoft, but these are IT organizations that handle company data and are not involved in actually developing the SQL Server software. And one of the organizations is comparing the average response time, so just queries as they come in from users, some of which will use the ColumnStore index and some won't. And the queries have not been tuned in any way to use the ColumnStore index other than just creating that index. And they're seeing that the average response time is 3.3 times better just by building ColumnStore indexes. In some of their internal testing, they found that 3 of their most long, painful reporting queries are now 50 times faster using ColumnStore indexes. And in that testing, they found that queries that used to take longer than 10 minutes, they saw a 90% reduction in the number of those queries, and the ones that they did see were just barely over 10 minutes. So these are some huge gains on real customer workloads. Let's talk now about best practices, how to get the most from your ColumnStore indexes. So first of all, you want to look at your workload. The ColumnStore indexes were designed for workloads that are typical data warehouse scenarios. So the workloads that are read mostly, you're mostly appending new data when you load data. The queries tend to be star join queries where you're joining a fact table to some number of dimension tables, and queries that scan and aggregate large data volumes just on one fact table. That's really the sweet spot for the ColumnStore index. And typically you'll use this when your workflow will allow you to either use partitioning to handle new data, or you can actually disable and rebuild the index on the entire table. So typically customers will have a nightly load window or some number of load windows multiple times a day or multiple times a week or a month or whatever works for you. And when you build your ColumnStore indexes, you'll typically do that on your large fact tables. And you may want to build ColumnStore indexes on large dimension tables. For the dimension tables, it's a trade-off between the size of the table and how often you need to update those tables. So the larger the fact table, or the larger the dimension table, the more value you'll get from the ColumnStore index because of speeding up the processing and speeding up the I/O and fetching only a subset of the columns. And you'll balance that against how often you want to make updates into those tables. When you build your ColumnStore index, you'll typically put all of the columns from your table into the index. So don't think of it as a way to just locate a row in the base table and seek into that table. Think of it as another access method, another access source for your data. Now when you create the ColumnStore index, as I mentioned, the order in which you list the columns is not important, and that's because SQL Server has its own way of determining how to order the data to get the best compression. If possible, you want to convert any decimal or numeric values that are precision greater than 18 to a precision of less than or equal to 18. And that's because you can't put columns that have a precision greater than 18 into the ColumnStore index. You would have to leave those out. And when your queries touch those columns, then SQL Server would use your base table, either a heap or a ColumnStore index or some other non-clustered index to satisfy that part of the query. While you can use other types of data in your ColumnStore, when possible, it's a best practice to use integer types. So the small int, big int, tiny int, regular int. And that's because you get a more compact representation and also more opportunity for early filtering. So we can push bitmap filters down into the ColumnStore index scan on some of these data types and speed up the query processing even more. Another thing to remember is you want to make sure that you have enough memory to build your ColumnStore index. Building the index is fairly memory intensive, and if you go and look at the FAQ that's in the resources in one of the later slides, we actually have a formula that will help you to estimate how much memory you need to build a ColumnStore index on a particular schema. And another trick, you don't need to do this. You can create a ColumnStore index on a heap. But if you create the ColumnStore index from a clustered index, if you have a lot of queries that filter on the key columns of your clustered index, you can see faster processing. And that's because we have a trick where we maintain metadata about the minimum and maximum values of some internal partitioning of the ColumnStore index. And we call those segments. And we can do segment elimination. That is, we don't even have to read some parts of the ColumnStore index if we can determine from the min and max values that that data won't be needed in this query because of a filter. And the index gets laid out in such a fashion that if you build it from a clustered index that's sorted on the key columns, more of those segments will be eliminated when you have queries with a filter on those columns. Another thing you can do to speed up your queries is to consider modifying them to hit the sweet spot for the ColumnStore index. As I mentioned, it was designed particularly to work well with queries that fit a star join pattern, and also to work with inner joins and aggregations. And what you'll see is if you have an outer join in your query, that outer join, although it can use the ColumnStore index, it won't use that batch mode processing. So if you don't really need an outer join, if you can change it to an inner join, you'll see it run a bit faster. Now you also want to make sure that you keep your statistics up to date, because the optimizer uses statistics on the table on which the ColumnStore index is created, just like it uses statistics to optimize other types of queries. And you'll get better query plans if your statistics are kept up to date. Now, as I mentioned, SQL Server determines the way to sort the ColumnStore index internally to get the best compression. And that means you won't get sorted data the way you can get from a B-tree index. So you might see an extra sort in your query plan if you need sorted data. Now the optimizer is pretty good at deciding when to use the ColumnStore index and when not to, but you can still use hints. You can use a hint to tell it to use the ColumnStore index or to use a different index. And we even have a new hint that you can say, for this query, just ignore the ColumnStore index. And then the final thing I want to mention is that the ColumnStore index, as wonderful as it is, it's not a magic bullet. You still have to pay attention to all the usual fundamentals of database design. So pay attention to the way you design your schema, the way you write your queries, and as I mentioned, cardinality estimates will affect the query plans that you get from the optimizer, just like for all other queries. So to wrap up, ColumnStore index technology plus this new advanced query processing is going to give you just an astonishing speed up for your data warehouse queries. You'll also see great compression with your ColumnStore indexes. And I want to thank you very much for watching this presentation. This slide has some resources that you can go look at later to get more information about ColumnStore indexes. And I just want to remind you to visit the Microsoft Virtual Academy, download the trial software if you haven't already, and start experimenting with those ColumnStore indexes, and participate in the other virtual launch activities as part of this special virtual launch event. Thank you very much.